Welcome to a video all about circles. Now, these circles are going to be in the context of conic sections, which is something that you may see at the end of Algebra 2, but is more likely to be in Precalculus and then maybe later on in math. So if you're looking for really low-level circle information, then this is not for you. So Precalculus, yeah. Pre-algebra, no. There are two formulas that we normally see associated with circles. The first one is called standard form, and standard form is going to be the form that we'd prefer to have it in because it tells us the most information. So if you can see this formula right here on my screen, this one right here, this is standard form for the equation of a circle that is centered at some arbitrary point h comma k with a radius some arbitrary r, and it looks like this whenever we write it out. So if we had values for h and k, what we would do, like let's say that this is 2 comma 3 or something like that, then what we would do is we'd put the 2 here where h is, and we'd put the 3 here where k is. And so because our formula has these minus signs, that means that we're going to be subtracting whatever these values are. So it's kind of like it changes the signs. If you have ever heard of the super secret opposite society, which you might not have because it is super secret, this is one of the times where that applies, that because we have parentheses in math, whenever we actually look at what's inside these parentheses, we need to think the opposite of what it really is. So if you see x minus 2, the part of that you want to take away is a positive 2, the opposite of what it actually reads as. And then with the radius, what happens is that that gets squared. So if our radius was 5, for instance, we would put 5 squared here, and we wouldn't just write 5 squared, we'd figure out what it is, and we'd write 25. That is standard form for the equation of a circle. The general form for the equation of a circle is x squared plus y squared plus dx plus ey plus f equals 0. D, e, and f in this situation are real numbers, any numbers you want them to be. It does matter that it's that our x squared and our y squared don't have coefficients. If they had coefficients, unless they were the same coefficient, then we could technically still maybe have a circle, but if you had different coefficients, that would be bad. And they also both need to be positive or both need to be negative. Again, like if you had things in front of x squared plus y squared, if you could divide the whole equation by something that they had in common, then maybe that would be fine, but for the most part, we're going to see things that just have x squared plus y squared. Standard form has huge advantages because we can get helpful information from it. What do you care about whenever you're thinking about circles? You care where the center is, you care what the radius is. Anything else you want to know about the circle comes from that information. And so if we ever see, we can actually take general form and switch it to standard form if we want to, if we feel like that would be a helpful thing for us to do. So we'll actually do that later. You have to use completing the square for that. So get ready for some fun. So how do we graph a circle given standard form? And also, how do we get helpful information from an equation that's in standard form? So here I've got x squared plus y squared equals 64. Now in our standard form equation we had parentheses and it said x minus h squared. We don't have parentheses, we just have an x that's being squared. So in case it wasn't obvious, that means that h would have had to have been 0. That's the only way that works. If it's anything other than 0, then we should have parentheses. So our center for this has to be at 0, 0, because we don't have parentheses with either of these. We're not adding or subtracting anything to our x or our y value. If you've already done things with transformations, you can think of our parentheses in our standard form as being transformations. That's what's happening to x is affecting how we move it left or right, and what's affecting y will move it up and down. And it does it the opposite of the way the sign originally tells us to, because it's part of the super secret opposite society. And we'll see what exactly that entails on the next example. The radius comes from the number on the right side, and we have to square root it. So the square root of 64 is 8, so r equals 8. So to graph this, we'd put a dot maybe in the middle for the center. You don't have to put a dot in the middle for the center, I don't guess. We want to go 8 each direction. And then you want to do your best to draw a circle. And let me tell you, that's hard enough on paper, but on a computer, it takes a lot of effort to draw even the most mediocre of circles. And really, like, I felt like I was doing decent at the halfway point, and then really had a wiggle here at the third quadrant, a wiggle at the end. So as long as your circle looks better than mine, then go for it. I notice students often accidentally make their circles or other figures that are like this kind of look very diamond-ish because they accidentally kind of draw straight lines in between points. So just put some effort into maybe rounding as you go around, make it look like a circle. It does not have to be perfect. Your teacher really most cares that it looks like you have the right radius and that you put some effort into it and that it looks like a circle, more so than other figures. Quick question, is this a function as we sometimes ask ourselves about relations in math? The answer would be no, because this does not pass the vertical line test. So it is not a function. You might have already realized that. Another big thing that makes things not a function is having a y squared automatically causes us problems for our functions, or not functions. It makes it not a function, the y squared does. What is the graph's domain? So what x values does our graph have? It looks like it goes to the left to -8, to the right to +8. There are no values for this circle that are past -8 and +8 on either side. And that's actually also true for the range. And I'm putting this in interval notation, and I messed that up for a second because it actually equals -8 and +8. So we want to put brackets to show that we are equal to at -8 and +8. That our circle actually touches those values. It's not that it gets as close as possible, but just misses it. So we actually touch those values. All right, that last one was centered at 0, 0, but this is not centered at 0, 0. We're going to take the values in our parentheses and use that to form the center of our circle. So the center comes from the opposite of this -2, because in our formula it says x minus h. So h in itself is a regular 2. And then our formula says y minus k. Well, we've got +6 here. So our k actually has to be a -6. So this is going to be a thing that happens a lot, that whenever you have parentheses and you're trying to take away information from those parentheses, that you actually use the opposite sign of what it has. So that -2 turns +2, the +6 turns into a -6. The radius comes from the right side over here. We square root that 9 and get 3. We're going to graph this. So we have to make sure to move over 2 and down 6. Again, you can think of that like a shift or a transformation. And then our radius is 3. So we're going to go 3 each direction. I find it really helpful to mark out 3 before I start drawing the circle, although it does kind of make it easy to do too much of a straight line instead of it being circular. But I think it's important, it's important to show your teacher that like you actually thought about the fact that it had a radius of 3 and you weren't just like, winging it and that sort of thing. Teachers appreciate effort a lot. The graph's domain. So left to right, our leftmost value is at -1 and our rightmost value is at 5. It touches both of those. So our domain is from -1 to 5. Our range, which is our y values, its lowest value is -9, then it heads all the way up to -3. So that would be our range. Now let's get to the good stuff. How to change from general form to standard form. In Algebra 2, maybe in Algebra 1, you were likely, or maybe hopefully shown that completing the square is a way that you can solve quadratic equations. But whether your teacher said this out loud or not, completing the square is one of the least helpful ways to solve a quadratic equation. And this right here is one of the real reasons why completing the square is a thing that is useful in the math world, because there's no other way to do this, at least not algebraically by hand, change this from general form to standard form. And so we're gonna look at completing the square. And so what we need to do is we need to separate out what we've got. We're going to put our x's together, so x squared plus 8x, and then I'm going to put a blank here. That's one of the places I'm going to complete the square. And I'm going to do my y's together, so y squared minus 2y, and then I'm going to put a blank. I'm going to go ahead and move this negative 8 over to the other side. So essentially what we're trying to do is algebraically rearrange this so that it looks like x either plus or minus something and y either plus or minus something equals something. Like, that's our goal, is to make it look like that. So completing the square is going to allow us to, for our x's, write this as x either plus a number or minus a number with a squared outside. So here's how completing the square works for those of us who've forgotten. We remember the good old Professor Hoffen squared and his method, where you take the number that's in front of x, which is an 8, you half that number and you square it. So you half 8 and get 4, and you square it and get 16. So I need to put plus 16 right here. If I do it on one side of my equation, I'm going to do it on the other side of my equation. Now, why was that helpful to put a plus 16 here? Ignore all the rest of our equation and just look at this part. Can you factor this into two parentheses? Is there something that multiplies together to get 16 that adds to get 8? Yes, 4 and 4. But since that's the same thing, we can write it as one parentheses with the squared and blah blah. That's what we're trying to do, is write this as x either plus something or x minus something with a squared so that it looks like standard form. Now we're going to do the same thing with our y's. We're going to say, what number do I need to put there so I can factor it? Now, you can go through the effort of trying to figure that out in some long strategic way, or you can just remember Hoffen squared. We're going to half the negative 2, then we're going to square it. That's the number that goes in the blank. So half it and get negative 1, and then you square it, and remember when you square a negative it turns positive, so I'm going to put plus 1 and make sure you do it to the other side as well and get plus 1, and then we're going to factor this, and you don't have to do this middle step unless you want to. What multiplies to get 1 and adds to get negative 2 is a negative 1 and a negative 1. It also works out that whatever number you got after you halved it, that's the number that should be in your parentheses. So this negative 2, whenever you half it, you get negative 1. It should always work out that way, that that's the number you need in here. 8 plus 16 plus 1 is 25. So now we have an equation in standard form. Now we can do all those wonderful things that we did on the examples before this if we want to. We can graph it, we can find the center and the radius, we can find the domain and range. We just needed it to be in standard form before we could do that. So there it is. Now, this is another completing the square problem, but in this problem, I have not nice numbers that I'm completing the square with. And so I just want you to know that going into it. If you're not interested in that, if you're like, no, my teacher's just given me all nice numbers, so I don't need to worry about this, then by all means skip ahead. Don't forget to like, comment, subscribe, and just, go about your merry way. But if there's a chance that you might have to face one of these terrible problems with really yucky completing the square, then please stick around and learn, because we want to put the x's together, and I'm going to leave a blank. We want to put the y's together, and leave a blank. I'm going to add the 6 over to the other side. Now the reason this is going to be yucky completing the square is because you can't half 5 evenly or half 9 evenly. So right off the bat, whenever you half 5, you might even be thinking, I can't half 5. That's not a thing I can do. You get 5 halves when you half 5. So then we need to square it. When you square a fraction, it squares the top and the bottom. So we need to add 25/4 here. Already you can see this is not an ideal situation. But wait, there's more. We're going to do that to the 9 as well. So we have 9 halves that we are going to square and get 81/4. So I'm going to add 81/4 to both sides. And then I'm going to write this as being in its factored form. Now this is where that hint that what should go in here should be half of the number in front of x is really, really helpful, so that you don't have to like struggle through the mind process yourself of getting there. Because half of 5 is 5 halves, this should be plus 5 halves. And because half of 9 is 9 halves, we're going to put plus 9 halves. And then we need to do 6 plus 25/4 plus 81/4. Let's change the 6 to being over 4. So 24 plus 25 plus 81, which is 130 over 4. And those are both divisible by 2, which means we get 65 halves. Now, if we were asked then to graph this, that would be terrible, because we would have to make our center be at -5 halves, -9 halves, and even worse, our radius would be the square root of 65 over 2, and in that case, I would recommend that you, if you're allowed to use your calculator, that you use a decimal approximation to just do the best you can. I don't think it's super likely that you'd be asked to graph something like that, but you never know. You just never know. So that's an example of gross completing the square for your pleasure. The other thing they can do, and you usually see this more with the other conic sections than you do with circles, is they can give you information and ask you to write the standard form of the equation, and that can go anywhere from easy, like this first one where they just give us the center and radius, to a little bit harder where instead of the radius they gave us the diameter, to actually they can get kind of crazy with it. It all boils down to figuring out how to take the information they gave you and turn it into a center and radius. So they might give you like equations of lines or endpoints of the diameter, and so you have to think about maybe even graph to help you like figure out how am I going to turn this information into a circle, or give up. I mean, that's also an option if you're just not, if it's not going well for you. So if we have the center and the radius, we just need to fill it in. Now, a thing that is going to be the case here is you put the x value of the center inside the parentheses with the x, because x affects x. There's a lot of sounding syllables. So I'm going to put x, and I'm going to change it to +3, because remember it's x minus h in our formula. So when I do x minus -3, it turns into +3. Then I'm going to do y minus 7, because it's y minus k, and this is k. And that equals our radius squared. So 10 squared is 100. So that would be the standard form of that circle. Here's center at the origin, diameter of 16. So we don't want the diameter, we want the radius. So we're going to half this, and that means our radius is 8. The center being at the origin, you can write x minus 0 and y minus 0 if you want to, but that is writing more than you need to. Mathematicians are generally lazy and want to write the least amount possible. So we'd rather not write x minus 0 parentheses squared. We'd just write x squared. And then the 8 needs to be squared to go on the right side, so that our answer is 64. Way to go, you made it to the end of the video. I'm so impressed because, you know what? There was that one example that was really something to get through. Even if you just skipped ahead to the end, I still props to you. Thank you so much for watching. Please give me a like, a subscribe, a comment. If there is something going on in your math life that you're needing help with, by all means let me know, and I'll see what I can do. And I look forward to seeing you in another video soon.